Thank you, Jessica. Good morning, everyone. Thank you for joining another series of our cybersecurity webinar partnered with Cisco Systems. So in the last couple of weeks, I think we've covered quite a few items: threat landscape, zero trust framework for workplace and workforce. Now today we're here to cover the zero trust framework for the workload, whether it's on-prem or on the cloud. So again, we're very happy to have Aaron Torres, the cybersecurity architect from Cisco Systems, to discuss what is zero trust framework for workload. So Aaron, here you go.
Absolutely. Thank you, everybody, for having me again. I have very much enjoyed doing these webinars for you guys and for everybody that's listening too. And today I'm going to be going over what I call workload of the Cisco Zero Trust model, and I am the most excited about this particular one, and mainly for the reason because, for me personally, visibility is probably one of the most important parts about security. I know a lot of people really enjoy going over the offensive side or defense, kind of like the red team, blue team type of approach. But for me personally, I kind of take myself away from that whole layout or organization, and I kind of look at it from a very high overview. And sometimes I think technology is too complicated. I think sometimes we overthink things, and sometimes with just the facts and truth of things really just kind of helps us zone in what the real problem is and allows us to focus into that area. So with that being said, again, thank you for joining today. If you have joined the last two webinars, you've obviously have heard of me and hopefully enjoyed some of the past presentations we've done about the Cisco Zero Trust model and framework. And thank you for joining again. If this is the first time you're joining us, I want to take some time to explain what Zero Trust is and kind of where workload fits in the Zero Trust model framework. So again, welcome. Thank you. As we know today, there's a lot of trends and things that we're seeing within the industry, right? And if we look at how the market or how the landscape looks with technology, you usually have desktops, laptops, devices that communicate to what we would call a corporate data center. And a lot of times those data centers were like the closet, right? Until you got big enough and got enough justification to build that enterprise network into maybe a bigger closet with some raised floors and an air condition, right? But more importantly, as a technology geek myself, a lot of times we were not looked as the saviors until something went wrong. And until we went out there, saved them, then we were considered heroes, right? They never just looked at us like, oh, you're Superman. We were always the person behind the yellow curtain, right? And with that, there's a lot of traditional designs when it came to technology. And as networks grew, there was a lot of updates to technology that allowed us to add that to our environment, such as cameras or surveillance or whatever it might be. And as an IT engineer, we got scared. We were like, oh, wait a minute. We have to manage cameras and now phones and then now other devices. Now we got to manage our the people on the network's personal devices. Those were all very scary things as we heard that, because before it was a handful just to control the servers and desktops and laptops we had to control. Now you're asking us to manage much, much more than that. And how do I go about securing those things, right? And as we see these devices expand in the world, we're starting to see things go into the mobility, either it being a handheld, iPad. Just to give you an example, my daughter has 6 devices just on her own. She has a laptop. She has a a watch that makes phone calls. She has an iPad. Then she has a device that she got from school for distant learning. So it's just the growing number of devices that we're monitoring or securing against or giving access to the network is growing, right? And as that grows, the demand for the infrastructure grows too. And nowadays, in not just in the future, but the present day, we're now seeing data centers being outgrown. And it's almost easier to use cloud applications such as Office 365, AWS, Salesforce, and etc., right? Why do I mention that? As an old school engineer, I was always the geek that always said, it's important for us to build our own stuff because I want to get my hands dirty. I wanted to configure those servers, regardless if my company needed it or not. I wanted to own it. I wanted to make sure it was secure because it was in front of me. Well, it's almost easier now to go to public cloud or other cloud solutions for applications because we're not liable for the downtime. We're not liable for the bandwidth, the reoccurring costs for the data center, or whatever it might be, the servers, or renewing those servers every 5 years, right? And more importantly, a lot of these applications are already developed and done for you. All you got to do is just enter in your domain and maybe your PKI infrastructure, which might be your certificates, and you got a pretty instant, application running for your environment pretty quick. But when we do those things, the things we have to take consideration are our perimeters disappeared. And now our perimeter is evolving. It may be for one particular person. The perimeter might be for one application. So we have to take consideration, what are we going to do to be able to visualize that design, how things communicate, either it being on-prem or off-prem. What's the stuff we're going to do to protect ourselves from viruses and malware or hackers or whatever it might be to infect or have access to critical information? Because now we might be putting critical information in the cloud, emails or human resources information, maybe patient record information. Anything could be leaked. And in the previous lifetime, we would get equipment or software that we'd put on site to protect us. But now, what do we do with equipment that we don't own? What do we do with places that we don't have visibility? It's not as easy as us to go walk to and be able to visualize what's going on in that network, right? So these are the new challenges that we have that's evolving in today's environment, which I want to kind of post a different twist here. And if you guys have ever heard me present in the past, I think you understand that I'm a realist in a lot of ways. And being a cybersecurity geek myself, there are tools and things out there from that you can use that allow us to penetrate, to hack, compromise, whatever it might be, and they're fairly easy. So for educational purposes only, I do recommend that you guys do Google or go to GitHub or some type of website out there that allows you to download these tools. One being, after Mr. Roa, F Society. They built a menu-driven Linux application that allows us to do pen testing, lack of better words, to hack. You can do information gathering. You can do brute force password attacks, wireless testing, exploitation tools, web hacking, private web hacking, post-exploitation, install and update. Or if you need to create your own payload and be able to have a reverse shell, which means that once you got infected with an exe or something that goes on in a Windows machine, I have access to that. And that means that I'm able to take remote control of that particular machine. Point being, either you're being a novice person to security or an expert in security, the world has made it easier for anyone to download these tools, either being an operating system or individual tools, to be able to hack or be able to take advantage of compromised or vulnerable systems in the world today. And it's not your fault. It's not the vendor's fault. It's not poor software fault. It's just the way the world is today. It's not a matter of when, a matter of you being protected. It's a matter of when you're going to be hacked. So having those risk assessments, having that thought process of what are we going to do when this does happen, that's the right mindset, because hackers are using what I call a framework. They have their own hacker guild, their own hacker framework that they're going to use. And a lot of it is just, basic recon, who is DNS lookups, man in the middle, information gathering, and then exploitation and post-exploitation. And if they're organized, why are we not organized? Why are we not taking the same approach in that type of model? And that's why Cisco came out with the zero trust model, to be able to, for us and helping our customers implement a model that allows us to protect their environments in the exact same way that hackers take to exploit us and our networks. For example, there are 3 different levels in the zero trust model. There's workforce, workplace, and workload. Today we'll be going over workload, but in the past 2 webinars, if you haven't been present for them, please go listen to them, or contact DataVox as our partner in crime here to go listen to those recordings. Workforce being that how are we protecting applications or rogue applications gaining access to a network? Workplace being how do we control secure access or securing users on-prem? And then workload being how are we looking at the workflows or looking at the applications being accessed on a network, and what are we doing to build visibility within that infrastructure? We believe that these are the exact same framework that a hacker would use, an experienced hacker would use to attack your environment. So why would we not use the same framework to be able to protect your environment? And zero trust usually means that you have to earn trust in order to gain access to anything. And by saying that, anything and everything that tries to gain access to the environment is untrusted. In order to gain trust, you must be able to gain access and be able to earn that. And you can lose trust while you have access to. From Cisco's point of view, not limited to, but here are some of the tools that we use. For example, the workforce, we believe like Duo is a good product that helps protect those mobile applications and making sure that we're using the appropriate authentication and device access within an environment. Well, as you know, that's the silver bullet. So when it gains access to a particular environment, we have to use the workplace with SD access or NAC solution, network access control, to either remediate or allow access dynamically within an environment, which means that once a user has access to an environment based on their role and how they authenticated, determines what access they have to applications or devices within that environment. Well, even then, we need to be able to monitor and respond to things within that environment. And just because they're on your environment does not mean they're accessing things in your environment. There might be access to Azure, AWS, Google Cloud, or applications somewhere else, or databases. And we need to make sure that we have visibility and that we're securing those flows between those devices within that environment, right? So let's focus on workload in this particular webinar. And let me kind of take the time into what it is. And in my past lifetime, I've spent many years in the visibility, application visibility, information gathering portion of the technology. And, for me at a younger age, I thought it was boring. I really did, because I really wanted to get my hands dirty. I wanted to feel that feeling of compromising something. I wanted to be able to hack something and steal something off some server. But my previous employers taught me that you don't know what you're attacking if you can't visualize what's going on. And that might be using scanners to scan an infrastructure, what's visible, what isn't visible, what's vulnerable, what isn't, what ports are open. You can't just aimlessly go in somewhere and start attacking things. You might be wasting your time. So they taught me strategically that you have to be able to monitor and visualize what's going on within an environment. So visibility in workloads is very important because it allows us to see what's running, or if something is critical that has vulnerabilities within an environment, I have that visualization. Then it allows me to essentially say, do I need to segment those particular applications, or if something did get compromised or doing something wrong, do I have the capability of containing that? Okay. So now that I've looked at the workflows and I can see that an application is reacting the way it should be, or if it isn't, do I have the capability of containing it? And then getting the alerts and communication. If a policy is being violated, what am I doing about it? How am I going to fix this? Or do I have the appropriate people to be able to look at that stack and be able to correct that compromise or contain that segmentation? So making sure that we create the correct controls from point to point, and making sure that we're securing not just hardware, but as well as the applications, virtual machines, containers, maybe the critical API calls between cloud and your data center. And that really is nothing, just an integration between software, and doing everything we can to make sure that we're minimizing that attack surface and that you have the least amount of privilege, meaning when something gains access to the network, that you have the least amount of privilege before you have access to those applications. And then that allows us to see what we call that flow of data. And once we identify what those flows of data are, then we can either allow and disallow it. That's what we consider a workload. Okay. Now, there are problems within any type of environment. And as I mentioned before, in a lot of our customer environments, I usually ask, do you have visibility of what applications are being used or who's doing what in your environment? And typically the answer I get is, well, my firewall allows me to see what websites are going to, or my web filtering. But if you have a data center, are you looking at the west and east traffic? What if something was already compromised? And can you visualize what's going on within your environment and not just at the firewall? And can you continuously look at that, as well as containing those breaches? Is your infrastructure, not just your firewall, because I feel that a lot of people rely on firewalls, does your switch or router or whatever environment that you have able to contain something based on the intel that you're being fed? And then be able to protect those environments, either being at a nano or micro-segmentation point of view. And just to explain the difference, a micro-segmentation might mean something, a group of machines, a group of IP addresses or subnets, but nano mean that we're adding that level of protection per host or per device, right? So when we look at workloads, we kind of look at three fundamental areas. And if you've heard me before, we look at these three fundamental areas for each one of these zero trust models. Are we establishing trust? Are we enforcing trust-based access? And are we continuously monitoring and verifying trust in those environments? So let's allocate how workload fits into that. So do we have visibility what's being run into this particular environment? And if so, do we trust it? Is it good enough, right? And then if it is, and it still gains access to our network, and it looks fine, but next week, all of a sudden, it has a breach, well, what are we doing to segment that traffic and to contain it? Well, let's say it does remediate itself and redeem itself and has access to the network again because it is normal traffic. Are we alerting the correct people or monitoring and responding to the indicators of compromises within an actual environment? So we continuously need to make sure that we're verifying trust within an environment. And to do that, we must have some way of visibility within an environment to identify that. So as we look at a traditional environment, right, we look at applications, communication, processes, network flows, and what is dependent on those flows in that environment. And to do that, you kind of look at your own environment as I'm speaking and thinking, well, how would I do that? How would I gain visibility? And a lot of people would say, well, I have snippers, or I have, Armon at the switch level, or I have, probes, or whatever it might be. And those are great. And it's good that, with Cisco, we have the ability of taking API calls and sharing context between different vendors. So we have the ability of sharing that context and be able to set actions and alerts based off that. And using your current investment of your infrastructure to look at that, either it being your current data center or your hybrid public or private cloud environment, and be able to get that information from that. So let's take the first part of that, right? Asking yourself, do I record every packet of flows of data of my users and or in my data center? And in data center, meaning your voice traffic, your application traffic, or maybe your cloud environment. And then you go, well, maybe yes or no. Well, the question then from that point is that if you're not monitoring your users, do you at least have flow data of applications that are critical in your environment, such as your applications? Maybe, maybe not, right? But are you using that data to be able to monitor how they're communicating with each other within your environment, not just to the internet, but just communicating to your users, your wireless users, your critical users, your critical networks? And then do you have the capability of identifying what software they have loaded? Why is that important? Because if something was compromised down at a server or an end user, I need to be able to identify or create a report on, did they install something that they weren't supposed to? Or did something get compromised through a PDF file on that particular machine and doing something on the back end? And do I have visibility or the trajectory of what's going on? And maybe simply for a compliance point of view, we need to be able to have the long-term retention of the data over a period of time. We all can agree that this sounds very complex, that this sounds very much a lot to do in order to gather this information. And a lot of this might require sensors or maybe gathering flow data from your current infrastructure. So you need to ask yourself, do I have the current infrastructure to be able to collect this data? And will I be able to look at that visibility? So instead of a vendor coming in there and saying, you must buy $3 million of probes and different hardware solutions to get the in-depth analysis that you need to analyze your environment, you need to take that step back and go, are they just selling me on something because it's their product? Or why can I not use the current infrastructure that I have, such as NetFlow or span ports or different types of solutions or software sensors you load on your current infrastructure to be able to visualize what's going on within that environment? And one of our key products that I like to talk about that is able to focus on this particular workload and use case is Cisco Tetration. And to kind of approach it from a neutral point of view, forget about Tetration. I'm not here to sell you or pitch Tetration, but it is part of our Zero Trust model. But it's important to have a solution in your Zero Trust model that gives you that visibility. And not just the real-time visibility, but the forensic. And back in the day, we would say, well, I need to know how much bandwidth or how much consumption our T1s or DSLs or whatever you might have are utilizing. Well, why is that important in security? Because sometimes overage amount of bandwidth could lead to a security problem, okay? Meaning that wares or data or something like that being sucked down from that environment from an exfiltration point of view. So having that forensics to be able to do that. But more importantly, what if they had a compromise or a vulnerability in an application that you're using? And that application is an HR product. How is that being acted, and why are people from Russia being able to communicate with that application? And who are those people? More importantly, I like visualizing what's going on in my environment. If there was a tool out there that could pretty much just lay out every flow on me in my environment, that'd be cool. But as we know, there's too many things going on, so I need something that can summarize it for me. More importantly, those graphs. To be able to visualize how something communicates from point A to point B and how it gets there is awesome. And then when I look at that, I need to know if an application is behaving, incorrectly, or if it was compromised, the processes in those particular servers, those machines, and be able to tell the difference between, is it a slow down the network or slow down the application, or maybe an application was crashed, to have that visibility without having to walk over to a desk to identify that. But to do those things from a security point of view, are we creating the correct policies matched to that visibility forensics? Are we using that forensic information to create those policies on my firewall, my switches, my ACLs, my honeypots, or whatever defense that you have within your environment? Because the days of a perimeter around the internet no longer exist. The perimeter is each device. I can't stress that enough. You need to take the approach of that. Once we have visibility of how flows look in your environment, that we must build a policy within every device in your environment, which also means kind of nano protection, nano segmentation. Then we need an ability to simulate those policies and what if scenarios and automate those and be able to identify, if this does happen, will this policy within my environment, within my firewall, within my switches, within my integrated security, within my network, protect me against it? And if it doesn't, or I notify something's wrong from my SIM tool or something out there, am I segmentating those devices, those applications, either being in a cloud or a local area? And then building violation compliance policies around that. Because to be honest with you, I like to sleep. I love golf. I try to play golf once or twice a week. That usually means I'm not in front of a computer, and I need to be alerted if a compliance or a policy was violated within my environment, and be notified if something goes wrong. Therefore, I don't have my boss calling me and saying that I'm fired because I wasn't there in front of my computer, right? So it's important that we have that mapping. And that mapping, understanding, just first of all, do I have an application in my environment? Am I monitoring the people that are using it? But not just from a user point of view. What about what the application relies on? Maybe there's a database. Maybe there's a web server. Maybe there's other clusters of servers or containers or whatever it might be within the environment that application relies on. So I need visualization, not just of the users, but the dependencies that the application uses to communicate in order for it to be in production. That might be functioning with a an automated server for scripts. It might be a database. It might be a front end for the web GUI, whatever it might be, whatever shared services it's using to be able to operate, we need that visualization. And not just from a user perspective. User information is great, but I need an app. I need a tool that allows me not just to visualize that, but to visualize the different aspects of flows and data from a security, from a network, from a capacity point of view, to be able to identify how things are communicating within the environment. Once I've identified how those communications are working, and I say, and I'll use gaming, the gaming industry as an example, right? We all probably been to Las Vegas. Some love it, some hate it. I personally love it. I'm sad that I can't go right now because of the whole COVID situation. I hope everybody's safe and I hope no one's had any health concerns. And if you are, my prayers are with you. But when I go to a casino, I can't help but sit back and think, how can I compromise this machine, right? And I'll use a great example. I went to Costa Rica maybe last year, the year before, with a dear friend of mine, very good friend of mine. And it was probably one of our first times to Costa Rica, and we stayed at a hotel kind of close to the beach, and it had a casino in it. And I was just kind of expecting that whole beautiful, very state-of-the-art casino that Vegas has. And I wasn't disappointed, but it wasn't. They had some really cool machines in there. But the funny thing about it, as I'm sitting there at the roulette table, they had this really cool lighting system that worked with everything, and it was flickering. It was being rebooted, and the dealer said, we can't make bets right now because we're rebooting the machine that handles the game. And I'm like, well, where is this machine? And she kind of pointed underneath the table, and I was like, oh, so the problem that we're having right now is actually a machine here, and I asked, is it wireless and network? Oh yeah, there's this cable, this blue cable is connected to it, and so unplugged it, unpowered it, plugged it back in, put the cable back in. And I'm kind of going, interesting. So I look at that, and I was thinking there's so many things in the back of my mind, not telling that person who I am, about all the different compromises, the compliance issues, the things that maybe in a normal environment in a casino that would never fly. Right? In a normal world, that machine probably would have been shut down and the software would have been loaded. It was a Windows machine, it really was. So I look at that and I go, well, how does my public Wi-Fi at this casino, do I have access to this machine? Can I compromise the machine? Has this machine not been compromised before, right? So having that mapping of knowing how does that machine communicate to its main server? How does it get its controls? How does it batch its wins and losses? How does it create its statistics, right? And if something were to go out of norm for that map, I want to be alerted, and I want to know what those tiers are and who's communicating with it and on what protocol. And if it is being allowed and it's going against the policies I've created, I want to know on what devices they were going through in order to gain access to that particular map. That to me is very important. And to do that, you must have some type of infrastructure that gives you the ability not only to visualize that, but as well as to quarantine and set access controls. An endpoint software that allows us to gather information about that device, either being its OS, its interface, its flow details, but being able to see how it's communicating to the network, and more importantly, how is it authenticating to be able to gain that device trust. And then having a network access control that allows us to gather that visibility and visualize that visibility, but be able to set actions based on that data. And if something is gaining access to the network that's not an approved OS or not an approved device, or is communicating with something that's not supposed to, what are we doing to quarantine that? Going back to that casino thing, what if that machine was compromised? They probably would take years or months to know that maybe someone was stealing data or someone was monitoring the statistics on how that machine wins, and someone was coming in every day to win and just gathering their salary that way. Be able to look at those patterns and look at the anomalies and be able to quarantine those things automatically is very important. And that's where segmentation comes in. Not only to be able to restrict by applications, but be able to restrict by users, device, cloud, multi-cloud, breaches, whatever it might be. And having that more importantly, be contained in an area and automated for you. I know 10 years ago, if you told me that security was automated, I'd be scared. But there's a lot better devices and tools out there in the world today that allow us to define that visibility. Because if you look 10 years ago, people didn't look at visibility and say, well, I'm going to block something because my firewall says this IPS is bad and we're going to block it. It may have blocked something good within your infrastructure because the threat intelligence wasn't good enough at times. Well, now that we have visibility within our customers' infrastructure, we now can make a better guess, right? And by doing that, as we look at the visibility within someone's environment, we're able to look at the on how things talk to each other and what the priority and rank is according to that flow, and setting an action or what if actions based off of those flows. Does your production talk to non-production? If it does, great. Who are those devices? If it talks to someone outside those list of non-production devices, I need to know who those are or learn by machine learning who those devices are so I can set a lower priority on them. And what is the overall action do I want to allow or deny traffic within those applications and infrastructure elements to be able to determine, do I need to automate this? And if it does this, do I have an automation tool that will block that or segment those tools or prevent them from communicating? And in today's working environment, we have really gone into a virtual world, right? Either being, creating vSAN environments and creating, virtual environments with VMware, Kubernetes, containers, Docker, using Docker within AWS, whatever it might be. We are now becoming a new world of networking, what I call virtual networking, right? You might use an SDN access to be able to control and configure all of it from the center of pane of glass. Regardless of what it is, we have to open our mind that programmability is something that's new to the world and it's becoming more better and more useful within our infrastructures. So APIs is strong and becoming more useful in combining these infrastructures together. So I always force my customers or their engineers to start looking at DevNet or DevOps. Okay, but understanding how those applications are developed and how they communicate, but also learning what those baselines are. Meaning not only identifying what devices you have within your environment, but observing how they communicate to the environment and building a baseline around that. For example, I might have a web server in AWS, right? And this web server might be communicating with this US-based machines or users. If for some reason it starts communicating with Russia or China with high amounts of traffic, I would consider that an anomaly, right? Something that's not normal. I need to be able to know that, is it communicating over the web traffic like everybody else in the US is? Or maybe it's using a non-standard port. And do I get the alerts on that? And is it doing workloads that maybe I should not be allowing? And if so, at that same time, we started noticing that our database servers that are in our data center that communicate with the cloud have a high amount of utilization at the same time. So we need the correlation of that. And if something does happen, not just segment the VM machine and take the whole infrastructure down, but can we segment those users or those flows to be able to offload them to make sure the application is still working, your business is still running? That's important. If you look at it from that nano perspective, what are we doing at a flow perspective from a segmentation point of view? Taking that workload off your current environment and making sure that we're not running into those particular problems. And then that also goes from an endpoint point. If we have users out there that are only financed by accessing something that they're not supposed to, like printers or anything like that, what are we doing to quarantine those users? Or maybe that's just that amount of traffic. From a zero trust model perspective, again, we don't trust anybody until you gain access. And if you gain access, these are the resources you have access to. Can we block those particular flows from accessing those devices? Now, we need to make sure that we enforce those micro-segmentation policies. What, again, going back to, how does micro-segmentation work? Well, I can't just create micro-segmentation based off an educated guess. It would be a lot more effective based off what I talked about with that flow data, right? And within that flow of data, we can use firewalls, or we can use the infrastructure to be able to block those non-production applications from talking with other applications, right? Or, for example, if Paul, that you heard talk earlier, got sick for some reason, and we're both in the same room, I can pretty much guarantee I'm going to get sick too, because he's sneezing, he's coughing. And if you've heard, I've used the example before, but maybe we build a bubble between us, right? And in that bubble, he sneezes, is contained in his own environment, but he can still function as a normal person. He can still do his job. He can still speak. He can still type and all that good stuff. But if I need to communicate with Paul for whatever reason, I could poke a straw between our bubbles and just speak to him over that straw and cover up that straw and open it when I need to. So that's effective because he's just not sneezing. I'm not just getting sick on it. But if I do open up that hole, there is still a chance, a smaller amount of chance, that I'll get infected with his flu or whatever it might be, because it's still a hole, a pinhole that might, but my chances are smaller, right? So from a micro-segmentation point of view, we're now enforcing these policies of these small little pinholes of what we're allowing access to. Well, just because we have those pinholes between those bubbles still means something can happen. So we need baselines. We need to be able to determine what is normal behavior within an environment. What are we doing to identify what those compromises are, and what are we going to do to block those communications? Building those policies and that compliance within that environment. Going back to those hacker tools that we talked about earlier that anyone here can use, you literally can do a scan of an environment. But that's how hackers do it. They do a spray of the environment to see what's open. Once they do that, then they focus on those particular machines that have vulnerabilities. So one thing that bothers me is when I have a compliance manager or a person that does a lot of reporting saying, oh, I saw this ping scan, or I saw this Nmap scan and it went away, so I'm not worried about it anymore. Excuse me, I would be extremely worried about it, because that means that they actually identified something that was vulnerable and they're not doing a scan anymore. They're actually focusing on that one machine and maybe encrypting that data so you can't see what they're doing. So what are we doing to enforce that compliance and identifying those deviations, not just in real time, but historically too? And then what are we, well, and I hope we're not just creating a whitelist or a block list. I hope we're doing something to enforce a policy management of how these things react within an actual environment, right? So if we look at how a baseline of how your network works, it's ever changing. So it's always adapting to the changes that your environment has. But either it being small packets or large packets or a web server or whatever it might be, we need to be able to identify, not just from a network perspective, but down to the server details of the processes the server is using, right? How things are being executed, what hashes they're using from an application, how those servers are communicating with other applications within the actual same server or a group of cluster servers. And if we see deviations outside that realm of reality that it's doing, I want to be alerted. I want to know why this application is communicating to another application on a server that has never been able to communicate before, and what data is it sending? Is it what I would call malware? Is it is something that has a security concern? I want to dig deeper. How many times have you asked somebody, hey, identify what that problem is? And they go, well, I think it's this. I think it's malware. Oh, it's malware because I actually saw on the machine, have ransomware and it stopped. By the time you get to that point, it's too late. We want to be able to detect the potential indication of a compromise early on, either it being a privilege escalation or execution of code or a PowerShell or whatever it might be from that particular machine, and stop it. And using that tool to be able to identify what are vulnerable from a software package perspective, identifying the unknowns, the 0 days before they became 0 days. Okay. And then what are we doing to set up policies to respond? Are we quarantining the host, quarantining those flows? Are we blocking the vulnerable machines? What is the policy or the remediation that we want to do to resolve the issue before it takes over the whole entire network, right? So with that being said, let's look at the whole overview of how that looks and how baselines work. Baselines look at network communications, being either from NetFlow or how data is being collected from the environment, your current infrastructure, current investment. Down from a device perspective, we're looking at process behavior, registry changes. We're looking at software vulnerabilities, and we're also looking at how applications are communicating. Then we're going to assess the impact if something goes wrong within these environments? And if something does go wrong, are we building policies, and are we using these policies within your whole infrastructure to block these things? And then how are we going to enforce enforcement, not just from internally, but your perimeter too as well, or your cloud? So let's say the problems that we have is communicating to AWS or Office 365. What tools are we using there to enforce that problem there, right? Maybe the problem came in from a phishing tool called Wingman coming from Office 365. So obviously, yeah, we need to block things with our infrastructure, but I need to go the root cause, and the root cause being that I have no anti-spam, or maybe my anti-spam solution bypassed it from a whitelist. I need to correct that at my cloud anti-spam solution. Today the whole hybrid cloud thing is very, very much there. A lot of people are still using private cloud, public cloud, local data centers. And as those communications happen, it's not just important to look at a tool that can collect that data and intel locally, but take it to VPC logs. The VPC logs are those logs that are generated within your public cloud like Azure or AWS, whatever, and visualizing that. They may not have a tool that allows you to look at it in a pretty environment, but here at Cisco we do. And then that allows us to look at that and how we might automate segmentation, even from a public cloud perspective, and contain things as we see things going through. And as we see that traffic, and as we see things, hey, things are working fine, the workloads are going through, things are communicating with it. But to be able to say, I see an automation of traffic is being denied because it was compromised, or maybe a user was trying to do something they're not supposed to. Maybe a user knew he was going to get fired, that was trying to steal Salesforce information, but he was denied because we have a policy that does not allow him to do that, right? It makes our life a little bit easier, not just from a real-time perspective, but identifying things from an orchestration point of view as well. And I mentioned this, and I know sometimes it's hard to understand all Cisco's terminology, but I bring up ACI, which is an application-centric infrastructure. Let me just kind of define what that is. In today's environments, we're used to, hey, here's a switch, here's a router, be done, be good, we're happy to go, right? ACI is a new way of looking how Cisco builds infrastructures. And we're catering the whole point of developing the network around the needs of the application. Before, it was you need to build your application around the needs of the network. I built the network here, we're good to go, design your application around it. We've flipped that, and we've realized that applications is what makes the network run in a lot of cases. An engineer, an application engineer, a network engineer, an application engineer would hate each other if I said that. But the reality is, it is coming to a point where we need to stop finger pointing the problems within the two people, the two groups. They need to come together. So from a cultural perspective, if you want my advice, something we need to do and make this change in all of our customers and partners' environments is start making realize that DevOps is in the middle, and that the network team, security team, and the application team need to come together and work together. Because ACI is an infrastructure and a framework, hardware and virtual, that allows us to combine application needs, servers, security, and switching and routing infrastructure together from a single pane of glass, and designing that infrastructure based off the needs of the application. It could be based on capacity, bandwidth, whatever it might be, but making that cloud environment via that infrastructure. And that's called application-centric infrastructure. And as we look at that, it's important that if anything was connected to that infrastructure, it's denied. It's zero trust. And that is why I'm talking about ACI, because as we look at secure data center, we kind of look at ACI, which is application-centric infrastructure, to say you have zero trust either from a flow or from a bare metal, a container, whatever it might be, until we gain access. We can quarantine a virtual machine if needed to, if we visualize something going to it that's not needed, or quarantine a flow of data going to that application in this cloud environment that we created through ACI automatically. That might be, for example, we have 3 virtual machines, application, web, and database. Everything's communicating, but just because you have access from the internet to the web server does not mean you have access to the database. If there was any reason that insights or some type of visibility tool saw the applications being, or database being accessed from the outside, that we need to be able to contain those workflows, automate that connectivity, and say, I'm going to deny you, and send an alert to the IT staff or the customer to identify what's going on and how am I going to block that via contract on the bare metal infrastructure or application or virtually before I quarantine the whole device. And obviously there's a level of load that you want to quarantine things, a whole device, when it's completely compromised. Or is there a way that we can do it on a nano perspective or from a flow perspective before we quarantine the whole thing? And that's what Workloads is all about, is allowing us to have that visualization that we typically would not have before, right? So how is this important to the whole stack, okay? And if you guys listened to me in my previous webinars, we talked about workforce, protecting devices and access to applications, right? The first level. Do I have multi-factor authentication? Am I using my correct username and password to gain access to Office 365 or whatever it might be? Biometrics, in remote workforce, what am I doing to gain access? Then once I have access to an inside network, I'm on the workplace. I need to make sure these devices are who they say they are, and if they're doing something bad, am I going to quarantine them? Am I going to remediate them, making sure that they're still secure, and having that network access control to contain those, and the enforcer. But all this cannot exist without workload, without knowing what connections I need to secure, without knowing how the flows of data work from a workforce or workplace perspective. We're making guesses. So when we look at the zero trust model, nothing's trusted unless it's earning trust, meaning by authentication, by verifying trust, and making sure that we have visibility into things and they're not doing something they're not supposed to. I hope that you see and understand why these three pillars are so important to enforcing what I would call policy-based controls as a whole solution. And this could be for Cisco, this could be for other vendors. But the point I want to get across is that I encourage every one of you guys to please take a look at a zero trust model, because as I said at the very beginning, that our hackers and the people that want to compromise your environment are using this model as a framework to compromise your environment. And there are so many layers to the onion underneath this to peel. I'm just hitting a very high overview. And I want to make sure that that you have us at Cisco to help you down this journey. But we also partner up with some of the best partners out there. And being that DataVox is one of those partners that we trust and has been through these trainings and has been through not only from a sales but from an engineering point of view, implementation, consultation, to help their customers understand how the zero trust model works. And it all starts with one step, an assessment. So if you're interested in an assessment, please reach out to your representative at DataVox. What they will do is sit down with you and evaluate what your model looks like today, and then set some equipment or hardware, software, whatever it might be in your environment to give you a full picture or a small picture of what's going on in your environment, and they can consult with you on what the gaps are. And those gaps are either missing hardware, missing software, or missing how you could be compromised today, or how they would take advantage, either from a social engineering, pen test, whatever it might be. That we want to make sure that this free assessment that they offer gives you the ability of visualization of what's going on within your environment, and that you could build a better zero trust model within your environment. So I want to say thank you for joining us today. I hope that this three-part series was useful and you gained some great insight and a better understanding of how zero trust works from a Cisco perspective. You're more than welcome to reach out to me or anyone at DataVox. But I just also want to send out a plug there, understanding that DataVox is doing a great job of sending this education, this knowledge to the people out there, and understanding that they want people to be educated. This isn't about trying to sell you something. This is about educating the customer and knowing that how does security work, and some of the things that we talked about, maybe even hacking webinars, right? But point being is, thank you for your time. We have an upcoming webinar for cybersecurity incident response and forensics and threats out there from a threat landscape perspective on July 8th at 10 a.m. Please register. We highly recommend it. It's a great one, and I hope you enjoyed it. So thank you for your time. And Paul or Jessica, back to you.
All right. Thank you, Aaron, for another informative session. Hope everybody gets a very good understanding of what really Zero Trust Framework can offer you from multiple different aspects of it. So with that being said, now that you have this understanding of the framework in place, so the next session that we're going to cover is the cybersecurity incident response. Why is it important? Is the due process procedure and all of that important to you? And what does it actually help, right? And so this is going to be the next session. It's going to be July 8th at 10 a.m. If you do not have that information, reach out to us and we'll send you that registration, or you can simply click on the link. So thank you very much, everyone. I'm going to hand it back to you, Jessica. Well, you know what? I forgot the Q&A. There are some Q&A questions that I have that actually I have it here that I haven't answered. So sorry about that, Jessica. Let me go ahead and ask these questions real quick. One of the questions is how does the Cisco workload protection differ from any traditional infrastructure protection?
Well, the difference really comes along with, if we look at a traditional infrastructure, it's manual, right? You have to use some tool out there, reporting tool, whatever it might be, to identify what threats or issues you have out there, create a VLAN or some type of container or whatever it might be to segment those issues. The Zero Trust model allows us not to give open access from the beginning. You must earn trust in order to gain access to that infrastructure, and it's not a manual process. A lot of this is dynamic or automated. So a lot of those VLANs, segmentation, VXVLANs, whatever it might be, are automated in the back end. So you don't have to worry about, paying this engineer 24/7 creating changes on a production environment when we have a software that's automating that for you. So it is drastically different. The concept's the same, but it's automating that process for you.
Okay, perfect. The next question is, how does the Cisco Workload Protection, which is Tetration, integrate with other security products and solutions?
So and I think one thing that you've heard me say numerous times, not just on this webinar, but in previous ones, is that I like taking the Zero Trust model as an open, vendor neutral perspective, because to think that everybody in the world has one vendor is not true. If you do, great. There's nothing wrong with that. But the truth of the matter is people might own different vendors. And with that being said, APIs and specifically with ICE, there's the PX grid that allows us to share context between different tools, either being through Tetration or being Splunk or Logarithm or SOAR platforms such as the Mesto and even our competitors, right? So is Zero Trust reliant on just Cisco? No. We obviously could take Intel or orchestration or orchestration tools from other products and be able to still build that Zero Trust model. So I guess I'm answering your question or I hope I am, is that it's not, you definitely could bring in third-party products and share that data. Absolutely.
That concludes our session for today. Thank you so much to Aaron and Cisco for a great presentation, and thank you all for joining us. Have a great rest of your day.